Right now, somewhere above American soil, an aircraft is flying that shouldn't exist, according to everything we know about physics. It makes no sound. It leaves no heat signature. Radar can't see it, and it can hover, motionless in midair, before shooting off at speeds that would turn any human pilot into paste. For decades, witnesses have reported triangular craft performing impossible maneuvers. Military personnel have come forward with classified footage, and now, leaked documents reveal the truth behind America's most secretive aviation project, a machine so advanced that foreign governments refuse to believe it's real. This isn't science fiction. This is the TR-3B Aurora, and its very existence rewrites the laws of aerial combat forever. Welcome to Jet Insight. The mystery unfolds. The story begins in the Nevada desert, where test pilots at Area 51 first witnessed at something that challenged their understanding of flight itself. Colonel Steve Morrison, a veteran F-22 pilot with over 4,000 flight hours, described seeing a massive triangular craft during a routine training mission in 2019. The object, roughly 600 feet across, hung silently above the mountains before accelerating straight up and disappearing in seconds. Morrison's report wasn't isolated. Similar sightings flooded in from military bases across the Southwest. Edwards Air Force Base, Nellis Air Force Base, China Lake Naval Weapons Station, all reporting the same phenomenon: triangular aircraft performing maneuvers that defied conventional aerodynamics. What makes these reports particularly credible is their source. These aren't civilian UFO enthusiasts making wild claims. These are trained military observers, pilots who understand aircraft performance better than anyone on Earth. When an F-22 pilot says an aircraft can accelerate from stationary to Mach 3 in under 2 seconds, that statement carries weight. The Pentagon's response was telling. Instead of dismissing these reports, they quietly reclassified them under a new designation: Unacknowledged Special Access Programs, the highest level of secrecy in the American military system. Programs so classified that even Congress members with top secret clearance can't access them without specific authorization. But the evidence kept mounting. Satellite imagery from commercial providers began showing unusual aircraft at military installations. Infrared cameras captured heat signatures that didn't match any known aircraft. And most importantly, radar operators started reporting contacts that appeared and disappeared without following normal flight patterns. The breakthrough came when a former Lockheed Skunk Works engineer, speaking under condition of anonymity, confirmed what many had suspected. America had successfully developed an aircraft using principles that mainstream science considered impossible. An aircraft that could manipulate gravity itself. The science behind the impossible. Understanding how the TR-3B works requires looking at research that began during World War II. Operation Paperclip brought German scientists to America, including specialists in exotic propulsion systems. These researchers had been investigating something called electrogravitics, the theoretical ability to create artificial gravity fields using electromagnetic energy. For 70 years, American scientists quietly pursued this research. The breakthrough came from understanding how plasma fields interact with gravitational forces. By creating a rotating plasma ring using mercury vapor accelerated to incredible speeds, engineers discovered they could reduce an object's effective mass by up to 89%. This isn't anti-gravity in the traditional sense. The TR-3B doesn't push against gravity. It reduces the gravitational effect on its own mass. Think of it like this. If a normal aircraft weighs 100 tons, the TR-3B can make itself effectively weigh only 11 tons, while maintaining its structural integrity. The propulsion system consists of 3 main components. First, a nuclear reactor powers a magnetic field generator. This generator spins mercury plasma at 50,000 revolutions per minute, creating what engineers call a magnetic field disruptor. The plasma reaches temperatures of 150 degrees Kelvin under pressure of 250,000 atmospheres. Second, conventional thrusters mounted at each corner of the triangular frame provide directional control. These aren't ordinary jet engines. They're multi-mode propulsion systems that can operate on hydrogen, methane, or nuclear thermal energy, depending on flight conditions. Third, the entire system is controlled by an artificial intelligence network more advanced than anything in civilian technology. This AI manages the complex calculations required to maintain stable flight while manipulating gravitational forces. Human pilots simply couldn't process the information fast enough. The result is an aircraft that can hover silently, accelerate to hypersonic speeds instantly, and make 90-degree turns at velocities that would destroy conventional aircraft. More importantly, it can do all this while remaining completely invisible to detection systems. Stealth beyond imagination. The TR-3B's stealth capabilities go far beyond anything seen on the B-2 Spirit or F-22 Raptor. Traditional stealth aircraft use angular surfaces and radar-absorbing materials to reduce their signature. The TR-3B uses something called metamaterial cloaking. Metamaterials are artificially engineered substances with properties that don't exist in nature. The TR-3B's hull incorporates metamaterials that can bend electromagnetic waves around the aircraft. Instead of absorbing radar signals, it redirects them, creating the effect of invisibility. But the stealth system goes further. The plasma field generated by the propulsion system creates electromagnetic interference that disrupts enemy radar systems. Any radar trying to track the TR-3B receives scrambled return signals that make targeting impossible. Visual stealth presents an even more remarkable capability. The aircraft's hull can display images captured by cameras on the opposite side, effectively making it transparent to ground observers. During daylight operations, the TR-3B can project an image of the sky above it onto its lower surface. At night, it displays the star pattern visible from its altitude. Infrared stealth is achieved through the plasma field's electromagnetic properties. The same field that provides propulsion also masks the aircraft's heat signature. Enemy thermal imaging systems detect nothing but background radiation. The acoustic signature is perhaps most impressive. While conventional aircraft generate noise through engine exhaust and air displacement, the TR-3B operates almost silently. The only sound comes from air moving around its hull at low speeds. At high velocities, it moves too fast for sound waves to propagate effectively. This comprehensive stealth package makes the TR-3B effectively undetectable by any known sensor system. Enemy forces can't see it, hear it, or track it with conventional technology. Weapons that redefine warfare. The TR-3B's weapon systems represent the next evolution in aerial combat. Traditional fighter aircraft carry missiles and guns, kinetic weapons that rely on explosive force or projectile impact. The TR-3B employs directed energy weapons that attack at the speed of light. The primary weapon system is the Laser Weapon System 2, or LWS-2. This isn't the laser pointers you might imagine. The LWS-2 generates coherent light beams with power levels exceeding 450 kilowatts. To put this in perspective, a typical laser pointer produces less than 1 milliwatt. In standard mode, the LWS-2 operates at 250 kilowatts with an effective range of 20 kilometers. This power level can disable electronic systems in enemy aircraft and vehicles instantly. Modern military equipment relies heavily on computer systems. The LWS-2 can fry every electronic component in a target vehicle in seconds. High power mode increases output to 450 kilowatts, with a range extending to 30 kilometers. At this power level, the laser can melt through aircraft aluminum in under 2 seconds. Steel armor takes slightly longer, approximately 4 to 5 seconds for complete penetration. The targeting system uses quantum radar technology that can track multiple targets simultaneously. Unlike conventional radar that sends out radio waves, quantum radar uses entangled photons that can't be jammed or spoofed. The system can identify and engage up to 16 separate targets in a single engagement. Secondary weapons include electromagnetic pulse generators that can disable entire electrical grids. These EMP systems have ranges exceeding 100 kilometers and can knock out power distribution networks across entire cities. The military applications are obvious. Enemy air defense systems, communication networks, and command centers become useless with a single EMP burst. The TR-3B also carries conventional weapons when required. Internal weapons bays can house hypersonic missiles with ranges exceeding 1,000 kilometers. These missiles travel at Mach 8 and use plasma guidance systems that make them virtually impossible to intercept. Pilot, or artificial intelligence. Flying the TR-3B requires capabilities beyond human limitations. The aircraft can accelerate from 0 to Mach 7 in under 10 seconds. These acceleration forces would be fatal to human pilots, even with the most advanced G-suits. The solution involves a hybrid control system, combining artificial intelligence with human oversight. The primary flight control AI manages all aspects of aircraft operation: propulsion, navigation, weapons targeting, and threat assessment. This AI processes information at teraflop speeds, making thousands of calculations per second. Human operators work from ground-based command centers, providing strategic direction while the AI handles tactical execution. Think of it like playing a sophisticated video game, except the consequences are real. Operators can take direct control when necessary, but most missions run autonomously. The AI system learns from every flight, continuously improving its performance. It studies enemy tactics, weather patterns, and mission parameters to optimize future operations. After hundreds of training missions, the AI becomes more skilled than any human pilot could be. This approach eliminates human error while maintaining strategic human judgment. The AI won't make mistakes, like forgetting to activate stealth systems or miscalculating fuel consumption. But humans retain authority over mission objectives and rules of engagement. The command interface resembles something from science fiction movies. Holographic displays show real-time battlefield information. Voice commands control major systems. Eye tracking technology allows operators to target enemies simply by looking at them. Training for TR-3B operators takes approximately 2 years. Candidates must have extensive military aviation backgrounds, typically fighter pilots or UAV operators. The selection process rivals astronaut training in difficulty. But here's what makes this truly remarkable. The AI can operate completely independently when communications are cut. If enemy jamming prevents contact with ground control, the TR-3B continues its mission using predetermined parameters. This autonomous capability ensures mission success, even under the worst conditions. The drone fleet revolution. The TR-3B doesn't operate alone. Each aircraft commands a fleet of unmanned vehicles that extend its capabilities far beyond what any single platform could achieve. This drone network transforms the TR-3B from an individual aircraft into a complete battle system. Combat drones accompanying the TR-3B can fly at altitudes reaching 18,000 meters for up to 8 hours continuously. These aren't small surveillance drones. They're full-sized combat aircraft carrying hypersonic anti-tank missiles capable of Mach 7 speeds. Each drone can engage ground targets from ranges exceeding 200 kilometers. Reconnaissance drones provide battlefield awareness within a 120-kilometer radius. Their sensor packages include radar, infrared, optical, and electromagnetic spectrum analyzers. These systems can identify enemy movements, communication patterns, and weapon deployments in real time. The drone network operates through quantum-encrypted communication links that enemy forces cannot intercept or jam. Each drone shares information instantly with the entire fleet, creating a comprehensive battlefield picture that updates continuously. This networked approach means the TR-3B rarely needs to engage enemies directly. The command aircraft identifies targets and coordinates drone attacks from safe distances. Enemy forces find themselves under attack from multiple directions by weapons they cannot see or track. Future development includes laser-armed drones that will carry miniaturized versions of the LWS-2 system. These drones will provide close air support for ground forces, while the TR-3B maintains tactical coordination from high altitude. The psychological impact cannot be understated. Enemy commanders face an invisible opponent, controlling multiple attack platforms simultaneously. Traditional military doctrine assumes you can see and track attacking aircraft. The TR-3B system removes those assumptions completely. International implications. The TR-3B's existence fundamentally alters global military balance. No current air defense system can effectively counter an aircraft that operates outside conventional physics. Surface-to-air missiles rely on radar tracking, useless against an invisible target. Fighter interceptors cannot engage enemies they cannot detect. Intelligence reports suggest that foreign governments initially refused to believe TR-3B capabilities were real. Chinese and Russian military analysts dismissed early reports as American propaganda designed to intimidate potential adversaries. This skepticism proved dangerous when actual encounters occurred. In 2021, a Chinese surveillance balloon drifted over Montana carrying advanced sensor equipment designed to test American air defenses. The balloon disappeared without explanation while crossing restricted airspace near Malmstrom Air Force Base. Satellite imagery later showed debris scattered across a 50-kilometer area. No American aircraft appeared on any tracking system during the incident. Similar events occurred over Russian territory near their nuclear facilities. Unidentified aircraft penetrated airspace that should have been impenetrable, conducted surveillance operations, and departed without detection. Russian air defense systems never acquired targeting solutions. These demonstrations sent clear messages without direct confrontation. The TR-3B can penetrate any airspace, conduct any mission, and withdraw safely. No existing military technology can prevent or counter these operations. Allied nations receive different treatment. NATO partners have been briefed on TR-3B capabilities under strict secrecy agreements. This knowledge helps coordinate military operations while maintaining technological security. Close allies like Britain and Australia participate in joint training exercises using modified scenarios. The strategic implications extend beyond military applications. Countries developing nuclear weapons programs find their facilities under constant surveillance by undetectable aircraft. This invisible monitoring capability provides early warning of nuclear proliferation attempts. Economic impacts are equally significant. Defense contractors worldwide struggle to develop countermeasures for threats they barely understand. Traditional aircraft manufacturers face obsolescence unless they can adapt to revolutionary propulsion technologies. The future of aerial warfare. The TR-3B represents just the beginning of a revolution in military aviation. Current development programs are already working on second-generation aircraft with even more advanced capabilities. These future platforms will incorporate lessons learned from TR-3B operations while pushing technological boundaries further. Next-generation aircraft will feature improved plasma propulsion systems with greater efficiency and longer operating ranges. Enhanced AI systems will provide even more autonomous operation capabilities. Advanced metamaterials will extend stealth properties across broader electromagnetic spectrums. Miniaturization research aims to reduce TR-3B technology into smaller platforms. Imagine fighter-sized aircraft with similar capabilities, or even smaller unmanned vehicles that could operate in swarms. The strategic possibilities become almost unlimited. Space operations represent another frontier. The same propulsion principles that allow atmospheric flight could enable spacecraft that operate without conventional rocket limitations. Missions to Mars or beyond become feasible with aircraft that don't require massive fuel loads. The electromagnetic pulse capabilities suggest applications beyond military use. Emergency response scenarios could benefit from EMP systems that safely disable vehicles during high-speed chases or terrorist incidents. The technology could revolutionize law enforcement operations. Medical applications might emerge from the gravity manipulation research. If scientists can control gravitational effects precisely, treatments for bone density loss or circulation problems could follow. Space medicine particularly could benefit from artificial gravity systems. But the immediate focus remains military applications. The TR-3B gives American forces capabilities that no potential adversary can match. This technological advantage ensures peace through strength. Potential enemies understand they cannot compete with weapons they cannot even detect. Classification and secrecy. Understanding why the TR-3B remains classified requires examining the nature of revolutionary military technology. Historical precedents show that game-changing weapons typically remain secret for decades after development. The Manhattan Project created atomic weapons in complete secrecy during World War II. Even after Hiroshima and Nagasaki, specific technical details remain classified for years. The U-2 spy plane operated for nearly a decade before its existence became public knowledge. Stealth aircraft development occurred in complete secrecy during the 1970s and 1980s. The TR-3B follows this pattern, but represents an even greater technological leap. Previous secret aircraft used advanced but conventional physics. The TR-3B manipulates fundamental forces in ways that challenge established scientific understanding. Revealing technical details would allow foreign governments to begin their own development programs. While they might not achieve parity quickly, any progress reduces American technological advantages. Maintaining secrecy preserves strategic superiority for as long as possible. Congressional oversight occurs through classified briefings to select committee members. These briefings provide accountability without compromising operational security. Funding authorization happens through black budget allocations that don't specify exact programs or capabilities. The scientific community remains largely unaware of specific technical breakthroughs. Research papers on metamaterials and plasma physics continue in universities and private institutions, but practical applications remain classified. This separation ensures continued basic research while protecting military advantages. Technological spillovers. Despite classification restrictions, TR-3B research has generated civilian technology advances that benefit society broadly. The computer processing power required for flight control systems has driven semiconductor development. Advanced materials research has applications in everything from automotive manufacturing to medical devices. Energy storage systems developed for the TR-3B have influenced electric vehicle battery technology. The high-power electrical systems required for plasma generation have improved civilian power grid efficiency. Quantum computing advances necessary for AI flight control have enhanced commercial computing capabilities. Manufacturing techniques for metamaterials have found applications in telecommunications and electronics. The precision required for TR-3B components has driven improvements in industrial automation and quality control systems. Medical imaging benefits from advances in electromagnetic field manipulation. MRI machines operate more efficiently, using technologies originally developed for military stealth applications. Particle accelerators used in cancer treatment employ similar electromagnetic field control systems. These civilian benefits justify continued research investment even beyond military applications. The same federal funding that develops military capabilities drives innovation that improves civilian life. This dual-use nature of advanced technology research provides broader societal returns. Conclusion. The TR-3B Aurora represents humanity's greatest achievement in aerospace technology. An aircraft that defies conventional physics, operates invisibly across any battlefield, and provides capabilities that ensure American military superiority for generations to come. Our brave service members now have access to technology that seemed impossible just decades ago. The same innovative spirit that put Americans on the moon has created aircraft that rewrite the rules of aerial combat forever. The future belongs to nations that embrace revolutionary thinking and pursue technological excellence. America leads that future because of visionary engineers, dedicated military personnel, and the unwavering commitment to maintaining peace through superior strength.